good morning. This is Dr. S. Subbalakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course differential equations and transforms, and now we are on to the topic Fourier series. In the previous videos, we have seen the concept of Fourier series and the problem regarding the same, and also we have computed the problem as well. In step 1, we have computed what is f of x. In step 2, we have found the value of a0, and step 3, we have found the value of an. In this video, we are going to compute the value of Bn here. What is the formula to find Bn? It is 1 by L integral c to c plus 2L f of x into sin n by x by L dx. In that, you are going to substitute L as pi and the limit as 0 to 2 pi here and f of x as x square. So what is your Bn now? 1 by pi integral 0 to 2 pi x square into sin n by x by pi dx. So this pi and this pi will get cancelled, so that the value becomes 1 by pi integral 0 to 2 pi x square into sin nx dx. So on integrating, you have to integrate this. For this, you are using the Bernoulli formula. So what is the Bernoulli formula discussed earlier? Integral UdV format. So in that, you are going to fix u as x square and dv as sin nx dx. On differentiating of the LHS, you have u dash is equal to 2x, u double dash is equal to 2 and u triple dash is equal to 0. As discussed, you have to compute till it reaches 0. And what is dv? dv is sin nx dx. So v is equal to minus 1 by n into cos nx. For how do you have this? Sin nx on integrating, you have cos nx, which is minus cos nx, and on differentiating this nx, you have 1 n that will be put up on the denominator. So the value of v here is minus 1 by n into cos nx. In a similar way, we are going to find dn v1. So on integrating cos nx, you have sin nx by n. So that n and this minus 1 by n will combine together. You will have minus 1 by n square into sin nx. So now what is v2? v2 is plus 1 by n cube, this minus, and on integrating this sin nx, you will have 1 more minus no. That will combine and that will become as 1 by n cube into cos nx. Now we have found all the values of the required Bernoulli formula. So we are going to substitute it. So Bn is equal to this 1 by pi into u into v. What is u? X square. V is minus 1 by n into cos nx plus or minus u dash into v1. U dash is 2x. v1 is minus 1 by n square into sin nx. That minus and this minus will get combined. And later on we have u double dash and v2. U double dash is 2 and v2 is 1 by n cube into cos nx. What is the definite limit given here? 0 to 2 pi. Now what we are going to do? We are going to apply the upper limit and the lower limit. So what do we have now? 1 by pi into, on applying the upper limit, as I have explained in the previous video, this will become 2n pi, this will become 2n pi, and this will become 2n pi. So cos 2n pi is 0, cos 2n pi is 1, sin 2n pi is 0, and cos 2n pi is 1. So this is what you are going to infer here. So this is x square, this is 1, therefore 2 pi the square into minus 1 by n into, this will become 1. This is clear? Plus this is 0 because sin 2n pi is 0 plus 2 divided by n cube into cos 2n pi is 1. Your upper limit is over. Minus the lower limit. What is the lower limit? It is 0. In place of x, you have to substitute 0. So this will become 0, this will become 0, and this cos 0 is 1. So the value here is 1 2 by n cube into 1. So these are all the remaining terms on applying the upper limit and the lower limit, which is equal to 1 by pi into 4 pi square minus 4 pi square divided by n plus 2 divided by n cube minus 2 divided by n. This is the value of Bn as of now. On simplifying, what you will have, this minus 2 by n cube plus 2 by n cube will get cancelled, and minus 4 pi square divided by pi into n. Therefore, what is the value of Bn? Which is equal to 4 pi divided by n. This is the value of Bn as of now. Now we have found the value of Bn to be as minus 4 by n pi. What is a0 from the previous video? It is 8 pi square divided by 3. What is an? It is 4 by n square. And what is bn? It is minus 4 pi by n. Now we have found all the Fourier's coefficients. We are going to substitute in the star equation. Therefore, what is your f of x? f of x is equal to a0 divided by 2. So 8 pi square divided by 3 divided by 2 plus summation n is equal to 1 to infinity an. What is an? It is 4 divided by n square into cos nx plus summation n is equal to 1 to infinity bn. What is bn? It is minus 4 pi divided by n into sin nx. So this is how we substitute the values of a naught, an and bn in the star equation. Now we will be simplifying it so that you will have 4 pi square divided by 3 plus here the variation is only for n, so the constant can be taken out. So 4 into summation n is equal to 1 to infinity cos nx divided by n square minus 4 can be taken outside and pi can also be taken outside since there is no variation here, and summation n is equal to 1 to infinity sin nx divided by n. So this is the actual Fourier series expansion for the given function f of x is equal to x squared. So this is how we compute the problem on Fourier series. Thank you.